Cumulus NetQ just fully unified data center operations from switch to server by adding support for the Kubernetes orchestration platform. NetQ directly interacts with the Kubernetes API to give you the visibility you need, all the way down into the container level. I'm Diane Paton, a technical marketing engineer with Cumulus Networks. Today, I will quickly discuss the unique challenges containers bring to data center networking, along with a demonstration using NetQ to troubleshoot a problem in a containerized environment with Kubernetes. Cumulus NetQ accelerates operations for all data center environments by ensuring the network is behaving as intended. It provides actionable insights by providing preventative services, thereby finding potential issues in a virtual environment before deployment. Proactive services, finding and alerting on potential issues before customers call, and diagnostic services, ability to view and troubleshoot the entire network from one location, both now and any time in the past. While NetQ supports all data center environments, it really goes above and beyond when you have containers or pods on your servers. Adding to our Docker Swarm support, NetQ 1.3 introduced support for Kubernetes, the most popular container orchestration system. Containers are constantly being deployed and destroyed, usually by an orchestration tool like Kubernetes, not a human. Therefore, the traffic pattern is rapidly changing also. But since the network team has no visibility into the host or the orchestration tools, they may not know why this is happening or be able to design the network for the agility it needs. They are also unaware of the location of the most important or revenue-generating applications to verify the network is operating cleanly to and from them. Likewise, the apps team often does not know how the containers are connected to the network. NetQ unifies the entire network visibility by integrating the containers and their deployments into the network view as a whole. This will allow either team to access the valuable data they need to do their job most effectively, and provides this access from any node in the network, the telemetry server, any switch, or any server in the network. But enough talk, let's do a demo. I'm going to use Cumulus in the Cloud for the demo. Cumulus in the Cloud, or CITC, is a free virtual data center provided by Cumulus to allow you some hands-on experience with Cumulus, using Cumulus VX and NetQ. Simply go to this URL and request a virtual data center by clicking Get Started. Then you can choose your experience. I'm choosing Kubernetes. You will get an email when the virtual data center is ready, along with access information. So this depicts the demo setup on CITC. We have BGP unnumbered infrastructure along with FRR routing on the host, also running BGP unnumbered, and advertising the container subnets into the infrastructure. We set up Kubernetes as the orchestration tool with Calico for IPAM. We have two Kubernetes deployments, called Apache 1 and Apache 2, that serve the customers. So the virtual data center is ready now and provides us access to the out-of-band management server, which is also the telemetry server. We can also access it directly by SSHing to this address over here, which is what I've done. So let's say we notice through our NetQ interface stats feature that traffic has drastically increased to one of our racks and we are unsure why. We are concerned this change of traffic will affect performance and want to get ahead of it, and know if we need to add an additional link. Is this just additional deployed containers, or is it something like a routing loop? So I'm on the out-of-band management server right now, and I can do all the commands from here, or the exact same commands from any switch or server in the network. So where would we start? Just to be sure, let's do a NetQ check BGP, and all looks fine here. And we can also do a NetQ check MTU, just to make sure there isn't any new fragmentation or anything weird going on. And that all looks fine. So we know the network has containers, so let's take a look at those. Since we're running Kubernetes with Docker Engine on the servers, let's take a look at which servers have Docker Engine installed with the NetQ show Docker summary. And this shows the Docker Engine version, the number of containers installed on each server, the number running, and the number of virtual networks on each server. And this all looks good. So next, let's take a look at the Kubernetes cluster with the NetQ show Kubernetes. And then, of course, we can always use tab to help us find the commands, and the tab complete works too. And we can see there are 4 nodes in the cluster. So let's see the recent changes to that cluster by adding changes. Okay, that looks good. We can see that no new nodes were added to the cluster since about 2.5 hours ago. So now we can move directly into looking at the Kubernetes deployments or application pods. if we do a NetQ show Kubernetes deployment cluster default, we can see all the deployments in that cluster. So what we can see here is a number of replicas now of that deployment, but let's see what was there some time ago. So let's see what was there, say, an hour ago with a NetQ show Kubernetes deployment cluster default around 1 hour. And we can see there are half as many pods then, which probably explains it. But where exactly are these new pods located? So we can see that too with NetQ by doing a NetQ show Kubernetes pod name, and then we'll add the deployment name. And then from one location, we can see not only where those pods are located, but their IP addresses also. And then we can also take a look at what that looked like 1 hour ago. And we can see there were 50% fewer containers deployed then. So now we can also easily see how they're connected to the network using a NetQ show Kubernetes deployment name, Apache 1, and then connectivity. So Kubernetes saw the load and scaled up the application, which is affecting our traffic flow. Now, if we had Notifier configured, we can also see those links to the containers coming up. But of course, that could be filtered out as well if we like. So let's say we want to swap out some hardware as an upgrade to support the traffic, which we expect to grow further. We can also use NetQ to determine the impact to our applications. This will help us decide when to do the swap out. Can I do it tonight at 7 p.m. or do I have to wait until the next official outage window? The command NetQ, and then the leaf we want to swap out, show impact, Kubernetes, deployment name, Apache 1, will tell us the impact to the deployment, Apache 1, if I remove leaf 1 from the network. And we can see in this instance that only 3 pods in this case would be affected at all, and only by 50% each. So a total of 15% of the entire deployment will be affected. So we can do that swap out tonight. So not only does Cumulus NetQ provide actionable insights into all environments, whether layer 2 or layer 3, but we recently included support for Kubernetes, as shown in the demo today. We interact directly with the Kubernetes API, providing unparalleled visibility into the data center as a whole, from switch to container on the server, to even interacting with the orchestration tool's API on the master server to provide instant access to information about the deployments. So get started today by using Cumulus in the cloud for yourself. Or you can download a demo from GitHub. You can also schedule a free demo. So contact Cumulus today. Thank you for watching and have a great day.